We all know that plastic pollution is one of the biggest threats that we are facing as society and as humankind. Plastics are contaminating our oceans and they have already entered in our food chain. Although the European Union is banning single-use plastics, they have already entered in our lives, and the solution is not going to be as easy as just banning some products. We also need to find sustainable alternatives to petrochemical materials. And here it is when bioplastics enter in the game. Bioplastics are materials with similar properties to the conventional ones, but they are renewable and biodegradable, so they can be produced from wastes and they can be degraded, for example, by composting. This amazing transformation from wastes to bioplastics is performed by microorganisms. It turns out that when microbes are exposed to environments where there is a lack of food, some of them will respond to these stress conditions by accumulating storage substances. This is analogous to the accumulation of fat in mammals, which will store extra energy to use in case of starvation. But bacteria accumulate polymers. They are called polyhydroxyalkanoids, or PHA, and they are polyesters with similar properties to polypropylene or polystyrene, for example. But the fact is that sometimes a product can be bio-based, renewable or biodegradable and still not be environmentally beneficial due to their production and processing chains. Because of this, it is necessary to validate the sustainability of bioproducts before they are introduced in the market. What we did was employing a waste stream that is highly available in our region, industrial fish canning wastewater, and test if it was possible to produce PHA employing these complex effluents. After almost 2 years of experiments, we managed to establish optimal conditions for the operation of the process, so our system would be ready to be upscaled once its environmental benefits are proved. Therefore, we compared the conventional treatments that are usually employed in the fish canning industries with our innovative system involving bacterial polyesters. And we found out that valorizing fish canning effluents into PHA was environmentally more favorable than just treating the wastewater. When we produce bioplastics, we are saving CO2 emissions and avoiding the use of petrol, so we generate environmental credits that are beneficial overall. PHA production would help to mitigate the effects of climate change and eutrophication, and would reduce impacts on human, marine and terrestrial ecotoxicity. By researching this process, we are moving one step forward towards circular economy, proving that systems based on bioeconomy are environmentally beneficial and that they have a huge potential to solve some of the most important challenges that we are facing, like the climate and plastic crisis and the sustainability of our economy and our lifestyle.